In this video, I'm just going to give you an overview of the project elements that bring all this together. So, starting with the world outliner, let's look at the main actor, which is our heli body actor blueprint. In here is a static mesh, and if we look at that static mesh, you can see that in there I've set up two sockets, one for blades and one for tail. And they're just positioned in the appropriate place. I have then also got two other actors which are being spawned in and attached to those sockets. So we have a blades actor, which is a static mesh, which has a rotating movement with the rotation rate set to 0 by default. If you recall in the demo, when I start, the blades aren't moving. When I press 1 on the keyboard, the blades increase in speed incrementally and build up to 2000 revolutions a second. And that is by changing this rotation rate value here dynamically using a timeline with an event track. So we're doing that for the main blades and then equally for the tail blades. And you can see the pivot points are at the center of, well, it's at the foot there actually on this one. So in our setup actor, which is just a blueprint actor that I've got some nodes and a post-process component. I'll go into it in great detail, but in effect what's happening here is we are attaching the blades to the sockets of that main actor. I've got some functionality to be able to change the field of view of the first person camera when I scroll up and down on the wheel. And then this is that keystroke one where I am affecting the blades and the tail blade actor and setting the rotation rate, but clamping that as well. I'll go over that more slowly. It's just to give you an overview on this video. The other things that are going on, so they're the only things that are actually in the world, UI setup and helicopter body. In terms of the widgets, I've then got one which is purely visual. It just helps define the zones. There's no interaction in here at all. I kind of ended up creating this because I just wanted to demark some sections of the screen so that I could see if my interactions were aligning with the boundaries that I'd set in the blueprint. I quite like this kind of quadrant UI aesthetic that came out of it, but that's an aside. And so the main widget that gives us a lot of the feedback is the child widget, which gets added to a blank UI material labels widget. So in there it's purely a canvas. That's the only thing that's in there. And the code that then adds the child widget, which is our pie chart. Within that pie chart I've got 3 images, small, medium, large, and the image itself is a material, and the material, I've created 3 versions of the material for small, medium and large for those pie charts. And in here this is handling the creation of our segment and control over that segment using a material parameter collection, pi small. When I change that scalar value, this in effect increases, it draws round. And then I've also got another one called pi scale, which is another scalar material parameter collection which deals with the minimizing of the pie charts when I hit the boundary edge on that version. So again, I'll go over that in greater detail. But the reason that I have created 3 versions is because I'm using a material parameter collection with 4 scalar parameters in here. So I've got pi small, pi medium and pi large. Now these drive the value represented on the pie chart. So basically how full the pie is. It's more of a kind of accelerometer really, or it's not sort of split. It's more a radial display. I just called it pie because that's what I called it. But it's a pie of one segment in this case. I've not done multi-segments in this demonstration. And then the fourth one is a pie scale, as mentioned, just deals with the minimizing when I change that value. And that's important. Now, the reason that I've done it using the material and having 3 versions of that material is because, as far as I know, you can't create dynamic material instances to affect images in widgets. So I had to create a separate material for small, medium and large circle. I don't know if there's a way of doing that. I don't know if that's a sort of C++ thing where I can add a material instance to an image in a widget. If anyone knows, please do let me know. I'd be really interested to know. This is my kind of workaround working with material parameter collection, because it's super powerful. You change it here and anything that calls upon that value gets updated at runtime. So it works really, really well in this demonstration, but I'm curious about the dynamic material instances for widgets. Is that even possible? Let me know. So I'm going to go into each of these actors in far more detail, but that's just an overview of the component parts to this project. And then last but not least is our UI material labels widget, which is just a canvas panel but houses the blueprint code to add our child widget, update on tick its position based on the marker actor in the world, and we'll swap out a few nodes to demonstrate each of the options in the Kopter demo. We've got a condition dealing with the borders, dealing with the quadrants. We've got the clamping code which I mentioned, which now retains the child widget within the boundary, and then I've also got the relative remapping using the map range clamp nodes to just alter the position on screen of the child widget constantly in relation to the marker actor in the world. So they're the 3 options, and then the 4th little bonus option of constraining and minimizing the child widget. So I hope that video is of use. If so, please do like and subscribe and hit the notification bell to receive any updates. And thank you for your support.